Cities and climate change. How does urbanization contribute to climate change? What are the effects on the cities, and how can GIS technology help? For most of human history, the majority of people lived in small communities. In recent decades, there has been a mass migration of people from rural to urban areas, determining an increase in the urbanization phenomenon. Nowadays, 55% of the world's population lives in urban areas. The percentage is projected to reach 70% up to 2050. Although it can seem like our expanding cities take up a lot of land, only around 1% of global land is defined as built-up area. Increasing urbanization brings with it many benefits. First of all, an economic benefit. Cities account for more than 80% of the global domestic product. The concentration of human capital in one place increases productivity and innovation, and from a social point of view, it creates strong local communities. Despite the many benefits, the characteristics of a city and its production and consumption systems make them one of the most vulnerable environments. Densely packed areas require a significant number of resources to provide for population needs, amplifying pressure on the environment and the dependence on external resources. Densification increases also the city's susceptibility to pandemics. On the contrary, unrestricted urban growth causes soil consumption and environmental degradation, intensifying the segregation of uses and increasing connectivity costs. Urban activities are also major sources of greenhouse gas emissions. Larger cities consume 2/3 of the world's energy and create over 70% of global CO2 emissions. Therefore, climate change is inextricably linked to urbanization. The increase in the frequency and intensity of extreme weather events causes damage to the urban infrastructures and affects citizens' quality of life. Rising global temperatures also affect the livability of urban centers. Due to the presence of heat-absorbing materials, lack of vegetation, and production of waste heat, these areas are often several degrees warmer than surrounding areas. These effects exacerbate air pollution in cities, causing an increase in chronic health conditions and morbidity and mortality risks due to a greater frequency of weather extremes. The financial effects of climate change can be as devastating as the physical ones, leading to major disruptions in business operations and city budgets. The distribution of these impacts on population is uneven. Most vulnerable social groups will experience greater loss of resources and greater impacts to livelihoods and cultural identity than others. Vulnerability is the inability to cope with external changes and hazards. Differential human vulnerability to environmental hazards results from a range of social, economic, historical, and political factors operating at different scales. The best way to reduce vulnerability to climate change effects is to improve cities' resilience. Resilience means the ability to face shocks and pursue structural changes in such a way that societal well-being is preserved. Building resilience in a city requires a systemic, integrated approach based on an effective climate change policy, including both mitigation and adaptation strategies. Mitigation efforts are aimed to prevent further climate change effects, tackling the causes, whilst adaptation efforts have the objective of reducing their negative effects. GIS and Earth observation systems allow us to observe where climate change effects have the most significant impact, but also to analyze different scenarios and model the future evolution of phenomena. As a result, GIS technology can help policymakers to choose the priority areas for intervention, as well as to decide the areas most favorable for the implementation of certain mitigation and adaptation measures. Through the observe, analyze, and take action flow, it has been possible to consider examples of climate change drivers and effects, to analyze their implication at local level, and to propose strategies for their mitigation. Drivers such as air pollution, land cover change. Air pollution has been observed in the case of Bucharest, in which it has been possible to estimate the areas with the greatest air pollution issues. This could lead to the identification of possible measures related to traffic reduction, development, or better management of green infrastructures. The phenomenon of land cover change has been observed in Lisbon. Land cover change data can be used to model future urbanization patterns and to understand if there is a necessity to control the expansion of urban areas. Effects such as urban heat island, flooding. The observation of the urban heat island effect can use data from meteorological stations or can be retrieved from satellite images. The analysis of the case of Barcelona allows the identification of the most affected city center areas. The most efficient ways of mitigating it are increasing green surfaces in the identified areas, planning measures aimed at reducing excessive urbanization. To observe the flooding phenomenon in Venice, bathymetric, meteorological, and hydrological data are used, as well as digital elevation models. GIS-based forecast models can be used to forecast the high tides and to understand where major protection measures are needed. GIS and Earth observation systems are powerful tools to be exploited to face the climate change effects in urban areas and to empower citizens and new generations to understand the local level implications and take actions to avoid further damages.